majority of PC gamers are still using 1080p displays, and I really don't think they should be, because actually running 1080p or something like it on a 1440p display looks better than it does on a 1080p display. But what do I mean by that? I don't mean you just go into your game and you set 1080p on a 1440p monitor. What I mean is you use DLSS upscaling, because if you run a game at 1080p native resolution, or you run on a 1440p display using DLSS quality, the internal rendering resolution of 1440p with DLSS quality is actually a little bit below 1080p resolution. It renders the game at 960p. However, it then applies the DLSS upscaling algorithm, which does have some performance cost, meaning it doesn't run quite as fast as running at 960p natively would, but the image quality ends up looking significantly better than a 1080p native image, and it actually runs about the same speed in frames per second as running a game at 1080p native. Now, the exact performance numbers can vary game by game. I tested out a wide variety of games for today's video at looking at 1080p native resolution up against 1440p DLSS quality. And in the vast majority of games, the performance was either better or about the same. And in general, it was about the same when comparing 1080p native versus 1440p DLSS quality. And in every case, I found that the image quality looked better with 1440p DLSS quality up against 1080p native resolution. It really does reconstruct the more close to the amount of detail you would see in a 1440p image, despite the fact that it's working with only an internal rendering resolution of 960p. You get a lot more detail. Now, there was one case where I found 1440p DLSS quality performed significantly worse than 1080p native, and that was specifically in Cyberpunk when using the Ultra Graphics preset. Now, why would this happen? Because if you actually use different settings within the same game, so for example, if you use the Ultra preset but add in RT reflections, then actually 1440p DLSS quality, again, is performing similarly to 1080p native. Now, why is this happening? Why would this matter game by game, and what graphics settings you're using? So not every setting a video game uses really scales performance-wise with the rendering resolution. Also, when you're using an upscaling algorithm like DLSS, not every part of the image is upscaled. Certain post-processing effects and various things, we don't need to drive way deep down into the weeds on this, but not everything gets scaled at that rendering resolution. So the point is that yes, it can vary game by game and depending on which graphic settings you're using, but in the overwhelming majority of games I tested, DLSS was not only available, but DLSS quality at 1440p did look better than 1080p, and it actually ran about the same as 1080p native. So, why would you maybe not want to get a 1440p display? I mean, for one thing, it costs money. But the thing is, monitors have been coming down in cost, especially when factoring in the amount of features and technology and just image quality that you're getting for it. A lot of people, I think, still have their 1080p display because they've had it for a long time, and it works, right? They're happy with the image quality that they're getting. They're happy with the refresh rate that you're getting. But if you haven't looked into it in the last 5 or 6 years, you might be surprised how good of a monitor you can get for under $300. So if you look at monitor review channels, like I personally really like Monitors Unboxed, I like to follow how monitors are, evolving over time. And it looks like you can get a great HDR experience at 1440p with a high refresh rate, variable refresh rate support for under $300. Now, this is if you've seen monitors claiming to be HDR in the past. But in the past, a lot of times they would be called HDR, and honestly, this still happens on the lower end models. They would be called HDR monitors despite not really giving you an HDR experience because they could accept an HDR signal. So you could turn on HDR in your Windows and your game settings and things like that, but it might not look great. To get a better HDR experience, you really want to have a full array local dimming setup. In other words, you want a kind of a grid of backlights behind the screen, which can individually brighten or dim different areas on the screen, which can really get you a better HDR effect. Now, the best HDR effect might come from more like an OLED panel, where each individual pixel can be adjusted independently or turned off completely for perfect black levels. However, OLED screens, prices are coming way down, but they're still pretty expensive. However, if you can start getting into the $700 to $800 range, you can get some really amazing 1440p OLED displays. But I will admit that's starting to get past where a lot of people are comfortable spending on a monitor. Although you might really want to look into it because in the end, whatever your game settings are running, you can crank all the graphic settings you want. The image you actually see at the end of the day is produced by the monitor. So having a good monitor can be a bigger graphics upgrade than turning up graphics settings, if that makes any sense, because you're actually seeing the image there. So do consider maybe expanding your budget for your monitor more than you may have originally been planning if you want to actually experience a good-looking game at the end of the day. But like I said, under $300, you can actually get reasonable 1440p HDR experiences. Although the trade-off on that is a lot of those cheaper HDR panels are VA panels, which don't have the best motion clarity. So if you're somebody who's chasing more of a high refresh rate, real smooth experience, then you can get a IPS panel, also for under $300, high refresh rate. Sounds like my kids are rolling things on the floor upstairs. We bought them office chairs for some little desks that they're in their bedrooms, and they like to use them almost like little go-karts. Like they'll lay on the chair on their belly and just roll across the hardwood floors. Apparently also while I'm making videos. So anyway, a little bonus info on the channel. But what was I talking about? Right, so 1440p displays. If you don't want to chase the HDR experience, then you can chase a higher refresh rate also for under that $300, and a higher refresh rate IPS panel can get some good motion clarity, still look very good. And again, if you're still sitting on a 1080p monitor, which maybe wasn't even that high refresh rate or wasn't that great of color quality, do you even have variable refresh rate support, things like that, you should seriously consider that upgrade. Again, under $300, you can get some really good stuff. Now, some people might be wondering, should I take this a step further and go up to 4K resolution? Well, the interesting thing here is 4K, when running at DLSS performance mode, is using an internal resolution of 1080p, and then it upscales it using DLSS, and in the end, the actual image looks far better than a 1080p native image. It is significant improvement. However, the upscaling algorithm going all the way from 1080p to 4K resolution is significantly more costly from a computation time perspective, meaning that where DLSS quality at 1440p ran at about the same frame rate as 1080p native in much of my testing, and sometimes faster, running at 4K DLSS performance mode generally runs noticeably slower than 1080p native. So I'm not saying you would want to completely steer clear of that, but I am saying just be aware that running 4K DLSS performance will run slower than native 1080p, so you do need to shell out for more GPU horsepower when you buy your graphics card. So that would increase the cost. Also, if you're considering going the 4K monitor route, just be aware that while 4K displays have also come down significantly in price for the feature set compared to where they were just a few years ago, that doesn't mean they're as affordable as 1440p displays. So if you want to get the higher refresh rates, HDR experiences and things like that, you might be adding on a few $100s more compared to getting similar specs but at 1440p resolution. So do keep that in mind. Now that being said, having that extra pixel count at 4K can look really good if you want to have a larger display. But I found that if you're at 27 inches or so, a 1440p screen running DLSS quality can look very, very good. And I'm not sure you're really going to get a bang for the buck value upgrade going to that 4K screen. Unless you're chasing a really large display. So if you're going up to you want to run like a very large display, get that really immersive kind of size experience, then you would want the higher pixel count. For example, I used to be using an LG C1 OLED TV over here, which is a 4K TV at 48 inches on my desk. And honestly, even 4K resolution sitting close to 48-inch display, I actually almost wanted a higher pixel count, which is one of the reasons why I've gone down to a 32-inch 4K display for the desk, because by taking that same number of pixels and shrinking it down to a smaller size, you get a higher pixel density. So you get a perception of more detail to the image. Although you do lose out on some of that size, which can be kind of a wow factor in certain situations. But I'll be doing a video about, or maybe I already will have done, I don't know what order I'll post these videos in, but very soon. I know people have been asking me about the 4K 240 OLED over here that switches to 1080p 480 hertz. I'll have a video about that as well soon. I've been wanting to try it out for a really long time to get some detailed thoughts. But anyway, that's kind of topic for another video. So what are we saying at the end of the day with today's video? 1440p displays are not actually harder to run when if you kick on DLSS quality than running a 1080p display at native resolution. In the vast majority of situations, your frame rate will be similar, but the image quality and the detail will be very noticeably better on the 1440p display. The display prices have come down on 1440p to where you can get actually reasonable HDR experiences, high refresh rate experiences with variable refresh rate support, good color accuracy, and motion clarity for under $300. So it can be an affordable upgrade, especially if you're maybe waiting on the next generation of graphics cards, right? If we're less than a year away from the 50 series or something like that, and you're like, I want to hold off on that, but I kind of want to upgrade my PC right now. I think upgrading to a decent 1440p display could be a surprisingly good upgrade for you. Now, the last thing is all of this was kind of depending on having access to DLSS. So you would want to make sure that you have a 20 or 30 or 40 series GPU if you're going that route. In this video, I wasn't using footage talking about FSR. I have other videos looking at FSR image quality versus DLSS, and there's just been the new FSR 3.1 and all of that. So I will say that what I said in this video performance-wise generally also applies to FSR. However, the quality of the output image is a little bit lower with FSR. Many people still find it fine and still find it to be an upgrade over the 1080p native image to use 1440p FSR at the quality setting. But there tends to be a bit more pixelation in motion compared to DLSS, which some people can find distracting. So that's a bit of a side topic. So do think about, again, the compatibility of your graphics card with the upscaling technology that you'd want to use. Anyway, I think that's what I've got for you guys today. Hopefully you found the video useful and or interesting, and I hope all of you have an excellent day.